In this example, we're given two trigonometric functions. We're given sine of theta and cosine of theta, and we're asked to find the tangent and cotangent of theta. So at first glance, it seems like a difficult question, but let's go ahead and actually draw a triangle to help figure out what's going on in this problem. And once we see this as a picture, I don't think it's going to be too bad at all. Here's what I want to notice. Both sine and cosine are positive in this case. So let me kind of make a note just to myself or off to the side. Sine and cosine are both positive. The reason that that's important is because when I go to draw my right triangle for this trigonometry stuff, I need to know what quadrant that triangle is in because it could be in any of the four. Well, what I want to think about is in which quadrant would sine and cosine both be positive. So that's where these four letters come back into play. Well, the only spot where sine and cosine would be positive is here in quadrant 1, where everything's positive. So we're going to draw the triangle in quadrant 1. So from the origin, I'll draw the hypotenuse in, I'll draw to the x-axis. Your theta is always going to be between the x-axis and your angle, just like a reference angle. And then here's how I can use SOHCAHTOA to label the sides of my triangle. So recall that when they give you sine, they're really telling you the opposite side over the hypotenuse. So the opposite side of that angle must be square root of 5. And the hypotenuse must be 5. Just a note for yourself, the hypotenuse will always be a positive number. So in some of these you'll have negative values and you'll have a choice of what you make negative. The hypotenuse will never be negative. Now they've given me more information, but let me just bring something up right now. Suppose they didn't even tell me what the cosine was. Could you still find out what that third side was? And hopefully you're yelling yes at your computer screen because you know that Pythagorean theorem would tell you that third side. So we could certainly do it that way, but this time they were nice to us and they gave us more information. Recall that cosine, the ka part of SOHCAHTOA, is the adjacent over the hypotenuse. Well, we already knew the hypotenuse was 5, but they're telling me, without having to do Pythagorean theorem, that the adjacent side is 2 square root of 5, although we would have got the same thing with Pythagorean theorem. Well, now that I have all three sides set up, finding the tangent of theta and the cotangent of theta shouldn't be too bad at all. So tangent is equal to the opposite over the adjacent. Well, the opposite side is here, square root of 5. And the adjacent side is down here, 2 over square root of 5. Notice too, all the numbers in my triangle were positive because if we're thinking of coordinates, we went to the right and we went up, so those numbers are both positive. Depending on what quadrant you're in though, some of those values may be negative, so just keep that in mind. Now I do need to simplify this. I cannot have the square root in the bottom of a fraction. Well, it's easy to simplify because the square roots just cross out. So the tangent of theta must be just 1/2, which is what we're looking for. Cotangent is just the reciprocal of that. So cotangent is just flip that around to get 2 over 1, or just 2 for the cotangent.